तो बच्चों आज हम टॉपिक शुरू करने जा रहे हैं इंटीग्रेशंस, वेरियस फार्मूलेस ऑफ इंटीग्रेशंस एंड substitution method. Today our topic is integrations and solution of the applications by substitution methods. Basic formulas of integrations are: first formula is integration of x raised to power n into dx, and here condition is that n cannot be equal to -1. The formula of first formula is, the first basic formula of the integration is integration of x raised to power n into dx, that is equal to x raised to power n plus 1 divided by n plus 1 plus constant of integration c, provided n not equal to -1. The value of n cannot be equal to -1, then the formula of integration of x raised to power n is into dx is x to the power n plus 1 upon n plus 1 plus c. The second formula is, if n is equal to -1, then this question becomes integration of 1 upon x. 1 upon x into dx is equal to log of x modulus plus c. This is the formula of the integration when n is equal to -1. The third basic formula of the integration is integration of e raised to power x into dx. As we know that integration is the reverse process of derivative, therefore integration of e raised to power x will be equal to e raised to power x plus constant of integration c, because derivative of e raised to power x is e raised to power x, therefore integration of e raised to power x is also e raised to power x. And fourth formula, that is the basic formula of the integration of a raised to power x into dx, that is equal to a raised to power x divided by log of a plus constant of integration c. This is the formula. Integration of a raised to power x is equal to a raised to power x divided by log of a, where if a is positive then it is log of a, and if a is negative then it is log of a modulus plus c. This is the fourth formula of the integrations. In case of derivative of a raised to power x, we have to multiply it by log a, and in case of integrations we have to divide by log a, then we get the formula of integrations. So these are the four basic formulas of the integrations. Now let us discuss the another trigonometrical formulas of the integrations. The first formula is integration of sin x dx is equal to minus cos x plus c. Because the derivative of minus cos x is sin x, therefore integration of sin x is minus cos x. Similarly, integration of cos x dx is sin x, because derivative of sin x is cos x, therefore integration of cos x is sin x. So this is the method by virtue of which you can claim these formulas. Dear students, derivative of sin x is positive and derivative of cos x is negative. But in case of integrations, derivative of integration of sin x is negative and integration of cos x is positive. The functions which start with the word CO have the negative derivative. Therefore, derivative of cos x is negative. But integration is a positive. Derivative of sin x is positive. But integration is a negative. These are the comparison by virtue of which you can claim the formulas of derivative and integration of sin and cos x. Third is integration of secant square x into dx is equal to tan x plus c, because derivative of tan x is secant square x, therefore integration of secant square x is tan x plus c. That is the constant of integrations. And fourth is integration of secant x into tan x dx, that is equal to secant x plus c, because derivative of secant x is secant x into tan x, therefore integration of secant x tan x is secant x plus c. And fifth is integration of cosecant square x into dx, because derivative of cot x is minus cosecant square x, therefore integration of cosecant square x into dx will be equal to minus cot x plus c, because derivative of cot x is equal to minus cosecant square x. In other words, derivative of minus cot x is cosecant square x. Therefore, integration of cosecant square x will be equal to minus cot x plus c. This is the trick which you have to apply it in order to find the integrations of the functions. Sixth formula is integration of cosecant x into cot x, that is equal to minus cosecant x plus c, because derivative of cosecant x is equal to minus cosecant x into cot x. In other words, derivative of minus cosecant x will be equal to plus cosecant x into cot x. Therefore, integration of cosecant x into cot x will be equal to minus cosecant x plus c. These are the basic formulas which we can derive from the formulas of the differentiations. And at last, we can find the derivative of now prove that integration of tan x into dx is equal to minus log of cos x modulus plus c or log of secant x modulus plus c. This can be proved by substitution method. So let us prove it. Let I is equal to integration of tan x into dx, that can be written as integration of sin x upon cos x into dx. because tan x is equal to sin x upon cos x. Here in this question, at the denominator we have cos x and at numerator we have sin x. If we put cos x, substitute cos x as z, then sin x dx will be dz after differentiation. And after substitution, these questions can be converted into basic formulas. And by applying the basic formulas and resubstitution, we will get the formula of integration of the tan x. So let us substitute. Let cos x is equal to z. Differentiating both sides with respect to x, we get d upon dx of cos x is equal to d upon dx of z. Substitution can be done in another variable. If here is x cos x, then cos x can be substituted as another variable, that is z. Cos x is equal to z. After differentiations, we will get derivative of cos x is equal to dz upon dx minus sin x is equal to dz upon dx. Therefore, minus sin x into dx will be is equal to dz. Taking negative sign to the right of this, we get sin x into dx, that is equal to minus dz. Hence, we can put cos x as z and sin x dx as minus dz. This question becomes I is equal to minus dz upon z. This question becomes this. Taking minus 1 outside, we get 1 by z into dz, and that is equal to minus log of z modulus plus c, because it is the basic formula that integration of 1 by x dx is equal to log of x modulus. Hence, integration of 1 by z dz will be equal to log of z modulus plus c, and this is the minus sign. After resubstitution, after putting the value of z, that is cos x, we get I is equal to minus log of cos x modulus plus c, and this is the formula of integration of tan x. Integration of tan x is minus log of cos x modulus, and its second formula can be proved by taking this negative sign at the power of cos x. We will get log of cos x raised to power minus 1, that is equal to 1 upon cos x, and that is equal to secant x. Hence, it will become I will be is equal to log of secant x plus c. After taking this negative sign to the power of cos x, we will get 1 upon cos x, and that will be equal to secant x. Therefore, this formula A can also be written as I is equal to log of secant x modulus plus c, and it can be proved by taking this negative sign to the power of cos x. That's all, and this is the formula which we have framed by substitution method. By substituting cos x is equal to z, we can prove that integration of tan x is this or this. That's all. Now let us derive another formula. Integration of cot x dx is equal to log of sin x modulus plus c. This formula can also be derived by substitution method. Solution, let I is equal to integration of cot x dx. Therefore, putting cot x is equal to cos x upon sin x, we get I is equal to integration of cos x upon sin x into dx. Substituting this denominator sin x as z or another variable z or t. Let sin x is equal to z. Substitution is done to change the complicated questions into simple formulas. By substituting sin x is equal to z, after differentiations with respect to x, we will get derivative of sin x is equal to dz upon dx. Derivative of sin x is cos x into dx multiplied by this dx. We get cos x dx is equal to dz. Therefore, this question becomes, after substitutions, this question becomes I is equal to add the numerator dz and add denominator z. That is equal to 1 by z dz. I is equal to 1 integration of 1 by z into dz. And that is the simple formula log of z modulus plus c. And putting the value of z, we get the formula of log of integration of cot x. That is log of sin x modulus plus c, because we have substitute z is equal to sin x. So this is the formula that integration of cot x is log of sin x modulus plus c, and this is the method. By substitution method we can prove this formula. Now let us discuss the another formula, that integration of secant x dx is equal to log of secant x plus tan x whole modulus plus c by substitution methods. Substitution method is helpful to find the integration of tan x, cot x, secant x and cosecant x. And this formula can also be proved by substitution method. Let us prove it. Let I is equal to integration of secant x into dx. Therefore, because we need that integration of secant x dx is equal to log of secant x plus tan x. Therefore, we must need secant x plus tan x at the denominator. And therefore, multiplying and dividing numerator and denominator of secant x by secant x plus tan x. Secant x plus tan x, multiplying and also dividing secant x plus tan x into dx. Multiplying numerator and denominator by secant x plus tan x, we get this. Therefore, this question becomes secant square x plus secant x into tan x divided by secant x plus tan x into dx. Now, at the denominator we have secant x plus tan x. If we substitute this secant x plus tan x z, then after differentiations we will get derivative of secant x is secant x into tan x, that is present at the denominator, and derivative of tan x is plus secant square x, that is also present at the numerator. Therefore, if we substitute secant x plus tan x z, then secant square x plus secant x into tan x will be equal to dz. Into dx will be equal to dz. Therefore, let us substitute. Let secant x plus tan x is equal to z. Differentiating both sides with respect to x, we get d upon dx of secant x plus tan x, that is equal to dz upon dx. And derivative of secant x is secant x into tan x. And derivative of tan x is secant square x. Hence we get secant x into tan x plus secant square x is equal to dz upon dx. Therefore, secant x into tan x plus secant square x into dx will be is equal to dz. This will be equal to dz. Hence, our question becomes integration of dz upon z. That is 1 by z into dz. That is equal to log of z modulus plus c. And after substituting the value of z, we get log of secant x plus tan x whole modulus plus c. Therefore, integration of secant x is log of secant x plus tan x whole modulus plus c. That is the formula of integration of secant x by substitution method. That's all.